Okay, so what we're doing is this is 10.1 and 10.2 for geometry. So what we're going to talk about is the properties of circles. That is the main, basically everything in these two sections is the main concept is introducing circles and the different properties and the different things that circles come with. So a lot of definitions, just follow along the best that you can, and then follow along when I draw some of this. This obviously is going to turn into a foldable. Properties of circles, it says a circle is a set of all points in a plane that are equidistant. That means equal distance from a point called the center. So basically we have a center, and that means every point, no matter where we go on the edge of the circle, will always be an equal distance. A segment whose endpoints are the center and any point on the circle is the radius. So we're going to draw a radius right now. I'm going to do that in red. So this is the radius from the center to the edge of the circle. That's what we call the radius. Okay? A chord is a segment whose endpoints are on a circle. Okay, so a chord, do that in a different color. That's considered a chord. It connects the endpoints, and it can be anything, but there's just an example of one. Okay, that's a chord. And then a diameter is a chord that goes through the center. Okay, so again, it does connect the two edges, like what we said, but because it goes through the center, that's called the diameter. Diameter is also twice the radius. So if the radius is 5, the diameter will be 10. And then a secant line is a line that intersects a circle at 2 points. So remember, these are segments. A line is going to go straight through. I know it's not straight, but close enough. Okay, that's what we call a secant. And then the last thing, a tangent line. A tangent line is a line that hits the edge of the circle on the outside, but does not go through. Okay, so let me find a good spot to draw this on. We'll do it right here. Okay, and that's on the outside, but it doesn't touch it. That's called a tangent. Okay, so those are the properties of the circle. Now let's talk about when we have two circles and what this means. It says two circles can intersect at 2 points, 1 point, or no points. Coplanar circles that intersect at 1 point are called tangent circles. So this right here, this is what we would call a tangent circle, or tangent circles. Okay, coplanar circles that have a common center are called concentric. So this over here is concentric. Okay, and it says a line, ray, or segment that is tangent to two coplanar circles is called a common tangent. Okay, so all of these are coplanar circles. Okay, but let's talk about the common tangent. So on our tangent circles here, a common tangent is a tangent line that will connect, that will be tangent to both circles. So we have one right there. We have one right there, and we actually have one right down the middle as well. I know these aren't straight lines, but I think you guys get the idea. So tangent circles actually have 3 common tangents. If we look at these circles right here, they have the intersection point and they overlap at one place. These ones, because they're not concentric, these actually have 1, those have 2 common tangents. Again, I apologize that I have non-straight lines, but again, same idea. There's 2 common tangents. And then over here with our concentric, they don't even cross, so we have no common tangents. Okay, so basically what we're looking at is we have two circles that are tangent circles, you'll get 3 common tangents. The ones that are not tangent circles but intersect will have 2 common tangents, and concentric ones where they have the same center, those will have no common tangents. Let's talk about a couple of the theorems now dealing with tangents, and these are pretty basic. Just try and follow along the best that you can. So, tangents of a circle theorem. It says, in a plane, a line is tangent to a circle right here, if and only if the line is perpendicular to a radius of the circle. In other words, if we have a tangent circle, then that means we will have a radius that will be perpendicular to that line. Okay? And this is the radius right here. And it can be anywhere. If I draw a radius to here, then we would have a line that is tangent to the circle that would be perpendicular to that. Okay? And then the second one, it says congruent tangents theorem. Tangent segments from a common external point. This right here is our common external point. So if we were to draw a tangent line to the circle from that point, so this right here is a tangent line, and this right here is a tangent line because it's brushing the outside of the circle, the theorem says that these 2 lines will be congruent. Okay, and that's what these 2 lines represent, is 2 congruent lines. Okay, so what I want to do is, based on these definitions right here, let's just go through, we're going to flip the paper over, and we're going to go through the 3 examples on the other side. All right, so in this first example, what it's asking us to do is we want to name each of these. So like DC. So DC is this segment right here. So what is it, what are we going to use to describe that? Well, if it's on the edge of the circle and going to the center, then DC is a radius. That's one of the definitions we just went over. BD, because it's connecting to, it's a segment that's connecting 2 ends of the circle. That's what we call it's a ray. So because it's a ray, I apologize. So because it's a ray, that is what we call a secant, because it's the entire thing. The ray keeps on going. Okay? And then part C, it's asking for the segment DE. And then part D, it's asking for the line AE. So what I want you to do is flip, you can do your foldable, and let's see if you can answer those on your own. So hit pause on this, so that way you can take 10, 15 seconds to answer these on your own, and then go ahead and hit play when you're ready so you can see if you're right. Okay, so hopefully for DE, it's a diameter because it goes through the center of the circle and it connects both 2 points on the edges of the circle. And then AE, because it goes through and brushes the outside and only hits 1 point on the circle, that's what we call a tangent. Okay, so let's look over at the next set. It says use this diagram to find the given lengths. Now, one thing we want to point out, A right here, that's the center of this circle, that's the smaller circle, and B is the center of the bigger circle. So the radius of B, we're starting here, and it doesn't matter which direction we go in, all we're doing is counting to the edge. So 1, 2, 3. So this is 3 units. Okay, so now if we wanted the diameter of A, 1, 2, 3, 4. So that's 4 units. Okay, so now again, on C and D, why don't you do that on your own, pause the video real quick, and come back and hit play when you're ready so you can see if you get the answers right. Okay, so for A, for the radius, again, that's only to the center of the circle. Hopefully you got 2 units for that. And then for the diameter of B, the big circle, that's all the way through, hopefully you got 6 units for that. Okay, so again, diameter is from one end to the other all the way through the center. Radius is only from the center to the edge. Okay, next example. So this goes off of the second part. It says tell how many common tangents the circles have, and draw them. So this one, because we have tangent circles, okay, we're going to have 3 common tangents because we're going to get a line right here. And again, these aren't going to be perfect, but you guys will get the right idea. Here's the second one. Those are a common tangent. And then the last one goes right down the center. So there's 3 of them. Okay? So what I want you to do is do the last 3 I want you to do B, C, and D on your own. Now that we've gone through that, use the other side of this if needed, and again, hit play when you are ready. All right, so for this one, it's similar to the one on the previous page. We just have two, one on top and one on bottom. The next one, we didn't really cover one on the other side, so this one can be a little bit tricky. You had to kind of use your imagination and figure out, how can I draw lines that will only touch one point on each one? Well, we obviously have one on top and bottom, but we also have one that cuts on the inside of each one of them, both up and down, left to right and right to left, going up and down. So that gives us 4. D should have been easy because even though it's not a concentric circle, there's no way that we can draw a line through these that's only going to brush the outside of them, so that one is none. Okay, let's look at the next set of examples based on the theorems that we talked about. It says in the diagram AB is the radius of circle A. It says, is BC tangent to A? Well, what we need to do is we're going to use the converse to the Pythagorean theorem. So basically what we're going to do is we're just going to check to see if the Pythagorean theorem works. Okay? Because if the Pythagorean theorem works, we will know that this is a right triangle. So what we're doing here is to find out, remember the theorem we just said is that this is a right angle if this is a tangent. Okay? So if this is a tangent, then this has to be a right angle. Okay, so we're trying to find out whether this line right here is tangent. So the way that we do that is we've got to figure out whether this actually, if the Pythagorean theorem works, because the Pythagorean theorem works with any right triangle. So the Pythagorean theorem, recall, is a squared plus b squared equals c squared. So what we're going to do is we're going to test that theory. We're going to do 60 squared plus 25 squared equals 67 squared. And all we're going to do is check to see whether that works or not. Okay? So that means we get 60 squared plus 25 squared is 4,225. And 67 squared is 4,489. Well, these need to be equal to each other. Because they're not, this is not a right triangle. Okay, so therefore BC is not tangent. Okay, and that's important because this theorem is important for us to be able to figure out whether we're getting right triangles or not. Okay, our last one, let's go through this, and then we will be done for this video, is it says DA is tangent at A and DB is tangent. So as soon as we know that both DA and DB are tangent, we automatically know that these two are equal to each other, so that's what we do. Once you know they're equal to each other, set them equal to each other. 6x minus 8 equals 28, and then just solve. So once we know that these two are supposed to be equal to each other, then we will set them equal to each other and then solve. So add 8, add 8. 6x equals 36. Divide by 6 on both sides. We get x equals 6. And that's it. It wanted us to solve for x. Okay? Because we know they're equal to each other, set them equal to each other. As soon as you know two things are equal to each other, just simply set them equal to each other and then go from there. Okay, so this is going to do it for, this is the 10.1 portion of it. We're going to finish the 10.2. It won't take long, only a few minutes, but we will finish that in a separate video. Just pay attention to instructions in class on whether I want you to watch both of these at the same time or if I want you to watch them on separate nights. Okay, so make sure you do your Edmodo quiz as needed and bring questions tomorrow.